So in the calculation of time period, Gurasis, we'll start first with the force method. Let's see कि कैसे करना है force method में. How do we do that? So I'll be taking up different scenarios. Fine.
Yes.
So सबसे पहला जो scenario है, that is spring block system. So in this, the first one is, suppose we have a spring and to it is connected a block of mass m. And we have to find out the time period of this system. So आप क्या करेंगे हर बार कि आप इस तरह से लिखेंगे, the first step will be in equilibrium. You will draw a free body diagram of this block in equilibrium.
Right.
So in equilibrium, there will be N and mg. There will be no force in the horizontal direction.
Right.
ठीक है? No force in horizontal direction. No force in direction of motion. ठीक है? Step 2. Displace it by x. अब हम ये मान रहे हैं कि ये अपने पोजीशन से x डिस्टेंस, मतलब मीन पोजीशन से, वेयर इक्विलिब्रियम पोजीशन से x डिस्टेंस डिस्प्लेस कर दिया गया है. So now I'll draw the free body diagram again. So suppose it has been displaced towards right. So n तो है ही, mg इधर की तरफ and kx spring force इधर की तरफ लग रहा है. Displacement x is in this direction. This has been displaced towards this direction, x. Got it? Then in step 3, we write the net restoring force. Restoring force is that force, fine, which acts towards the mean position. Net restoring force is the force which acts towards the mean position. So if you see this diagram, so net restoring force will be minus kx. Why I have chosen minus is because
opposite direction.
Opposite to x. The force is opposite to x. I'm taking the direction of displacement as positive. Direction of displacement is positive. Keep this in mind. So once I get FR, so I can say acceleration will be minus k by m into x. Then I will compare step 4. Compare with a is equal to minus omega square x. So this implies that omega is k by m under root. So time period is 2 pi by omega. So this is 2 pi under root m by k. Understood? This is how you have to proceed. This 4 step. Equilibrium का free body diagram बनाएंगे, displace it by x करेंगे, net restoring force लिखेंगे और last में compare करेंगे. Let's take another situation. This is m, this is k. So फिर से मैं एकदम step wise लिखूंगा ताकि आपको ये एक बार clear हो सके. Step 1, in equilibrium. So this time in equilibrium there is some force mg and there will be some extension in the spring in the equilibrium position also. Because mg will pull downward, so for equilibrium to reach there has to be some elongation. So in equilibrium, this time in the direction of motion there will be some force, and I like kx naught minus mg is 0 or kx naught is equal to mg. Let's call this as equation number 1. ठीक है. Step 2, displace it by x from equilibrium. इक्विलिब्रियम से ये आप x डिस्प्लेस कर रहे हैं. सपोज हम ये मान लेते हैं कि इट इज बीइंग डिस्प्लेस्ड इन द डाउनवर्ड डायरेक्शन. नाउ if I draw the free body diagram, so the force mg तो अभी भी नीचे की तरफ होगा, सेम लग रहा होगा, but force in the upward direction will become what? Already x naught था, तो x naught plus x हो जाएगा ना. स्प्रिंग में जो फोर्स होता है that depends on total extension, पूरी पोजीशन से. So this is the diagram. X is in the downward direction. Step 3, net restoring force. The force which bring it back to the mean position. Net restoring force Fr is mg plus minus k x naught plus x. डायरेक्शन ऑफ डिस्प्लेसमेंट को पॉजिटिव लेंगे. तो हमारे पास Fr जो हो जाएगा वो हो जाएगा mg minus k x naught minus k x. तो दिस विल कैंसल आउट बिकॉज हमने पहले स्टेप में प्रूव किया है कि k x naught इक्वल्स टू mg है. तो हमारे पास रिस्टोरिंग फोर्स हो जाएगा माइनस के एक्स. तो एक्सेलरेशन हो जाएगा माइनस के बाय एम इंटू एक्स. सो स्टेप 4, कंपेयर विथ a equals to minus omega square x. So I get omega as k by m under root. So time period is 2 pi by omega, that is 2 pi under root m by k. Again the same answer.
Right.